Hi guys, we're now going to be applying the perpendicular bisector theorem, which states that if a point lies on a perpendicular bisector, then it should be equidistant or the same distance to each endpoint of the segment that the bisector is intersecting with. So, if we can spot a perpendicular bisector, and if we can spot a sneaky little point that lies on that perpendicular bisector, then we can apply the perpendicular bisector theorem. So let's see what we can find. Which, if you guys see here, line WX, it's heading on its own little way, and then all of a sudden it hits segment ZY, and this nifty little boxy thing forms, which is a 90-degree angle. So this is perpendicular, line WX is perpendicular to segment ZY because it's hitting that thing at a 90-degree angle. Whoa. So I already know that it's perpendicular. And then, do you guys see here that ZX is congruent to XY? Whoa, holy hot dog, right? So, when something slices something in half, it makes two congruent segments. What that means is that a segment or a line is bisecting it. So, guess what, you guys? Line WX is not only perpendicular to ZY, it's also bisecting it because it creates two congruent segments. Holy hot dog, so you know what that means. Now we can apply the perpendicular bisector theorem. Yes. All right, let's get going. So I know that line WX is perpendicular, or is the perpendicular bisector, sorry. It's a perpendicular bisector, which means we can apply the perpendicular bisector theorem. Yay! So you cannot apply this theorem unless you first figure out if you have a perpendicular bisector. So that is very important. So watch yourself. Okay, so with that being said, now that I have a point on that perpendicular bisector, if you guys see here, point W is located on WX, which is a perpendicular bisector. So, if we use the perpendicular bisector theorem, what that states is that it will be equidistant to each endpoint along the line that has the perpendicular bisector, or in this case, the segment. So, these two pieces right here will be congruent because point W is located on WX. So, it will be the same distance to each endpoint, the same distance to Z as it is to Y. Holy hot dog, right? Pretty cool, right? So that means that WZ is congruent to WY. And if their lengths are congruent, that means that if the two segments are congruent, that means that their lengths are equal. All right, so that might help me solve. We'll have to see. Okay, so first we need to solve this thing for X, which if you guys notice, our x's along segments WZ and WY. So why don't we substitute in the values of WZ and WY? So WZ equals 2x plus 11, and WY equals 4x minus 5. All right, and guess what, you guys? We have an equation that contains x's now. So guess what? I can solve for x. All right, let's get going, you guys. So currently, the x's are on separate sides of my equation, and they are besties. It's wrong to keep besties apart. So I need to move 2x to the other side to join its best friend, which is the 4x. So I'm going to move 2x to the other side, which 2x minus 2x will cancel and turn to 0. 4x minus 2x will become 2x. So now I'm left with 11 equals 2x minus 5. All right, you guys, so now that my x's have been joined together, now I need to get x on one side by itself, which currently that negative 5 is getting in the way. It's seriously irking me. So let's move negative 5 to the other side by adding it on both sides. Let's add that thing. So negative 5 plus 5 will cancel and turn to 0. 11 plus 5 will give me 16. So I have 16 equals 2x. Okay, you guys, I'm really close to solving for x, okay? That 2 is secretly multiplying to the x, so the way I move that bad boy over is by dividing that thing, the opposite of multiplication. So 2 divided by 2 will cancel and turn to 1. 16 divided by 2 means that x will be 18. I'm sorry, not 18. Jeez, the demon cash just got me. 8. Sorry, guys. So x equals 8. Yay! But we are not done solving for the problem. We now need to find the length of wy and the length of wz. All right, let's set these things up. So wy equals 4x minus 5. All right, and wz equals 2x plus 11. And that's my z, you guys. Put a line through it because sometimes my z's start looking like 2's, and I don't want you to get confused and think I'm writing a 2. So that is a z, so just be careful with that. All right, so wz is 2x plus 11. All right, which, now that I know x is 8, how can I use x being 8 to solve for wy and wz? Oh man, you guys always know the right answer. Gosh, I should have learned from you guys, not the other way around. But anyway, so since x equals 8, I simply substitute an 8 for x, and that will help me to solve for my values. So I have 4 times 8. My x will transform into an 8. All right, and 4 times 8 will give me a 32. And 32 minus 5, that will be 27. Yay! So I currently know what one of my segment lengths is. Now I need to find what the other segment length will be, which technically, since I know these two are equal, technically, I already know that WZ should be 27, but it doesn't hurt to check, right? Sometimes we get the wrong answer for X, so it's good to know when we're solving if you have the right answer or not. So I'm going to substitute an 8 for my X to see if we get 27. If we don't, then I might need to redo this problem, and that's embarrassing. Okay, so let's see. All right, so we have 2 times my X, which is 8, plus 11. So I'm going to replace X with 8. All right, let's see what happens, you guys. So WZ equals 2 times 8, which is 16. And oh man, let's see if it equals that. I hope it does. This is making me nervous. All right, let's see. WZ equals 16 plus 11, which, holy hot dog, you guys, is 27. Yay! That's exciting. So I'm going to put a smiley face because I'm glad we got the same answer. So these two are equal, which is awesome, right? All right, nice job, you guys. In example 2, we'll be applying the converse of the perpendicular bisector theorem. So get pumped up for that.